to hook up a new widget to the board, and you just you weren't figuring out, you wasn't making sense. What would be some of the first things you do?
What?
So
A widget, a piece of electronics.
we
So
have.
it could be an actuator.
I'm gonna bring a box of widgets. I'm gonna pass everybody a unique widget, and you can tell me how would you start investigating.
Would you try to find the library?
How's it going, man?
So I'm hearing, I'm going to read between the lines there. Google it, right? You say search for device drivers. To me, I mean, you're gonna try to go just scour the internet randomly for references on people how they've interfaced to it before.
Yeah, that's what most people do. So
Okay.
I would assume that
Were you breaking it down a little bit further? Like,
Yeah.
Okay.
because I remember you saying that you need device drivers, so you would contact you if you couldn't find it, or someone that's in your department, ask for a device driver for your device, see if you had one. And mainly GitHub, I would say, when you search for libraries there.
Yeah. What type of library would you look for?
At this point, I don't know what widget it is.
And that's what I say. The first thing you'd want to look for is a Linux kernel driver. So not just any driver. I mean, with the RFID, we kind of got stymied trying to find a kernel driver beyond the SPI-dev interface. But for everything else, for the audio, for the what's the other thing? The other stuff that we're hooking up, you can find a kernel driver, and there's a kernel driver for the vast majority of the stuff that you look for. Then the question again becomes like, where would you look for? Like you can Google it, but where else would you go to try to find a kernel driver?
That's a good question. I don't know if this
Okay.
hardware plan is really necessary for me to pass these things around. So we'll
Yeah.
continue on the path that you.
The kernel sources, right? So you can find the kernel sources at kernel.org, right? I pointed to several links on documentation on kernel.org.
That's good.
But you can actually search the sources. So if you're in doubt of where to find code to talk to a certain device, the thing I would suggest you first place you start looking for it. You can Google it just to get a general idea, but start looking in the kernel sources specifically.
So should we go to the Google Doc and open the one or two links? Did you share a link where we can find kernel sources on here? Is that what you're saying?
There are links inside the slide, yes.
Oh, in the slides, sorry.
At kernel.org.
Okay.
And when you Google, you can try to search. You can include kernel sources in your search terms and things like that. But
Okay, so should we use a specific example to try to work through it?
sure. How about that magnetometer?
Okay.
Okay. What's the part number?
You mean our standalone magnetometer, our breakout board,
Yeah.
or the one on the?
The standalone magnetometer. So something new,
That one is.
or anything else.
Yep. It's a PMOD CMPS. The magnetometer itself. Let's go to.
I'll tell you that what the board is matters less than what the chip is.
Right,
just so
right.
you know.
CMPS2. It's gonna. If we just go to the Digilant store or site, that'll tell us what's the name of the chip.
What's the chip?
So it's using the MEMSIX MMC 341.
What MM6?
Sorry, MEMSIX is the brand.
How do you spell that?
MEMSIC apostrophe S.
Okay.
And then MMC 34160PJ.
Okay. Were you done with this? This is the right.
Yep.
Thank you.
Linux kernel source.
Is that one?
Yes.
What's the difference between that and what I searched for? M34.
Looks the same.
Yeah, okay, that one has it. Alright, not finding it on Google, so kernel.org.
Datasheet.
Or browse the sources. You can search for commit logs within here.
So,
This is you should be able to find the same thing by Googling. I'm just trying to show where
Yep.
the type of place where you really want to be finding the results.
yeah, this is new to me, so this is useful.
All right, we can get a little bit smarter in that this is drivers. Almost all of these are going to be IO, and this is a magnetometer. So we can get down to the folder where it's most likely to be.
How did you get from just kernel.org to right here?
This is kernel.org.
Yep.
Very focused on the software. There's browse the source, mainline.
Mainline browse.
I could look at one of the LTSs. We're right now we're running the latest LTS, which is the long-term support branch. So that's where instead of getting all of the very latest changes, you get a version that just has patches placed on it that fix bugs and security holes. That's what a long-term support is. Does that make sense?
I don't see the long-term.
Right here, long-term. It just
Okay,
says long-term.
Okay.
So a long-term branch is one that is continuing to get bug fixes and particularly around security, but it's one that's continuing to get bug fixes. A long-term branch does not get new features. New features go into mainline, and so that's where the development happens is in mainline.
So if
But
you-
when somebody fixes a bug in mainline, the maintainers also apply that bug fix to the long-term branches.
They get paid?
They do.
That's good.
The Linux Foundation pays them. Not everybody doing that work gets paid. A lot of it is volunteer, but most of the volunteer are more like me volunteer. I have a full-time job at Texas Instruments where part of my job is working with the Linux kernel, therefore it's part of my job to maintain the Linux kernel. Although I have one patch in the Linux kernel, but don't tell anybody. But that's the idea. Is it's people that most of the people are professionals. That's part of their job. Greg Crow-Hartman, who's is the guy that actually owns that repo for the long-term support branch. But he doesn't do it all himself. He has lieutenants, some of which are,
Getting his pays?
a lot of which are quote unquote volunteer, but are still paid.
Yeah.
So we click browse. This is like GitHub. This is like kernel.org's GitHub. You can look at our GitHub that has our kernel sources. They're all just branches of each other, right? Do you know what I mean by saying they're branches of each other?
General, yes. But so
Well, there's the one Linux,
copied it.
but there's like we use the word forks, but there's the forks as a copy where it doesn't always look exactly the same because we don't apply every single change to those forks. So not every patch gets done identical. Like the difference between like each one of those is a fork. So these are all snapshots in time for which there have been 70 releases on this against this, and 185 releases, 185 against that one, 133, and 58 against that branch, right? So the first two digits are where they broke off at this point, and then these are releases that have been made against those. The last digit would be individual releases. We're about, I think 5.2 just got released, like within the last week or so, something like that.
7.7, right?
Up to 3. Yep.
And how do you know what exactly the new features are?
Well, that's
On in the long term. So like right now you just see mainline and long term. So you'd have to go in there and read exactly.
it can be fairly complicated.
Okay.
All the changes. So there's a couple different places where people kind of summarize it.
Mhm.
The definitive answer, of course, is to look at the change log. The change log could be very long, right? So this is the list of changes in this release, right? You can look at that individual change log. There's a great site called lwn.net. I think it's called the Linux Weather Report or something like that. You can subscribe for access, but in their blog posts, these guys are probably the best at talking about new kernel features.
Okay.
Statistics in the 5.2 kernel. So who's writing the kernel? You can find what, like, a lot of times they'll break it down by different companies that people are contributing. Intel's the top. TI used to be in the top 5 or 6. It looks like we've slipped over recent years. A lot more has gone into Lenaro, which is a united ARM development. So a lot of people working for different ARM manufacturers will contribute through this company called Lenaro, which is kind of that umbrella of different ARM companies that all contribute and work together in Lenaro. Yeah, we know those Beaglebone guys.
So, back to the CMPs.
Well, I wanted to just, the one thing I got distracted about, the thing I was looking for is like, how do you really know the features? And there's, I wanted to look at the release. I haven't read the release on 5.2 yet, and it would be, there should be an article here on the 5.2 release. I see statistics. I don't see a feature set release. Anyway, people write blog posts that tell you nice summaries of what got done, but they essentially scour through the change set and look for interesting things to talk about, like support for a new board, or support for a new architecture or something like that. That gets changed, but essentially look at the things. Also, when you let's just browse the mainline source. There's commit logs, and often, so this is the commit that Linus used to tag 5.2. Right. The very last change, all he did was remove this extra version. It said it was a release candidate for 5.2, and he just took that away and said, okay, it's good. Right. His last change was to remove the extra version, so it's no longer 5.2 release candidate 7. It was just 5.2. So that was the very last change before it was tagged. A lot of times in the commit log, there'll be a nice message where he talks about it. He might summarize some of it, but anyway, this is all the summary of the different changes that occurred in 5.2. If you look at any particular file, right? So we were going to go into drivers.io because that's where magnetometers are. If you look at any particular file, this is the magnetometer for that's inside the MPU 9250. You can get a log of the changes specifically to that file.
Right.
This is common on GitHub and other things that browse version control libraries, right? But the kernel.org one has that same facility. You can actually look at the history on the individual